This is the EdExcel GCSE 91 Maths Foundation Paper 2, which is a calculated paper, and it's from the Specimen Set 2 papers. Question number 1. We have to write 6,819 to the nearest 1,000. Well, if I draw a number line, if we were to write this number correct to the nearest 1,000, our answer will be in between 6,000 and 7,000. We've got our halfway point, 6,500, and our number 6,819 is 6,500 and more, so we will round up to the 7,000. Question number 2. We have to write these temperatures in order. Start with the lowest temperature. Well, the lowest temperature is -5 degrees C, followed by the -2 degrees C, followed by the 3 degrees C, followed by the 7 degrees C, followed by the 10 degrees C. Question number 3. We have to write 0.075 as a fraction. Give your answer in its simplest form. Well, in our calculator, if we type in 0.075, we get 3/40. Our calculator simplifies for us the result. So we have 3/40. Number 4. We have to find the value of 5 to the power of 4. Well, let's type this into our calculator. We've got 5 to the power of 4. It turns out we get 625. Question number 5. Living to 100 years old. 1 in 3 babies born last year are expected to live to 100 years old. We've got 720,000 babies who were born last year. How many of these babies are expected to live to 100 years old? Well, what we need to do is work out 1/3 of 720,000. So we've got 1/3 of 720,000, and if we work this out, we get 240,000. So we would expect 240,000 babies of these 720,000 to live to 100 years old. Question number 6 here is part of a train timetable from Swindon to London. For part A, how long should the 6:58 train from Swindon take to get to London? So we've got Swindon, and the time the train leaves Swindon is 6:58, and the time it will take then to get to London, well, it arrives in London at 8:02. So the difference between these, well, if I add on 2 minutes, I get to 7, and add on another hour, I get to 8 o'clock, and then another 2 minutes after that, I get to 8:02. So in total, it takes 1 hour, 2 minutes, rather 1 hour, 4 minutes. For the next part, Claire says all these trains take more than 1 hour to get from Swindon to London. Is correct. You must give a reason for your answer. Well, if I take a look at this 7:17 train, it arrives in London at 8:14, and that's less than 1 hour. Well, the Swindon to London train from 7:17 to 8:14, that takes less than an hour. It actually takes 57 minutes, so therefore Claire is incorrect. Question 7. Tracy buys 2 coffees at £1.10 each, 3 teas at 95p each, and 5 sandwiches at £2.15 each. Tracy shares the total cost equally between 5 people. How much does each person pay? So, the total amount of money, we get 2 coffees at £1.10 each. Then we have 3 teas at 95p each. And then we've got 5 sandwiches at £2.15. So let's work out the total cost. It turns out the total cost is £15.80. So the amount they would pay each, if they split it equally between 5 people, we've got 15.80 divided by 5, which is equal to 3.16. Question number 8. Rachel carried out a survey of 10 people to find out the type of fruit they like best. The table gives information about her results. For part A, which type of fruit is the mode? Well, mode means most common, so we are looking for the one with the highest number of people. The highest number of people is 5, which corresponds to banana. For part B, in Rachel's survey, 2 out of the 10 people like apple best. We have to write 2 out of 10 as a percentage. Well, we've got 2 out of 10. And if I was to write this out of percentage, well, percentage means out of 100. So 2 out of 10 is equivalent to 20 out of 100. So we have 20%. So we have 20%. P also carried out a survey to find out the type of fruit people like best. He asked 30 people which type of fruit they like best. He drew this pie chart for his results. A smaller proportion of people like bananas best in Pete's survey than in Rachel's survey. We have to explain how Pete's pie chart and Rachel's table show this. So, from Rachel's results, we've got 5 out of 10 who like banana. So, 5 out of 10 like banana from Rachel, which is half the people she asked. Now, if we take a look at banana from Pete's survey, what we would have is less than half. So from Pete, less than 1/2 like banana, which supports those results. Question number 9. The smallest angle of a triangle is 25 degrees. The triangle is enlarged by a scale factor of 3. Ben says the smallest angle of the enlarged triangle is 75 degrees because 25 times 3 is 75. Is Ben right? Explain your answer. Well, no, because when enlarging shapes, lengths change by a scale factor, not the angle. Question number 10. Carol ran in a race. The graph shows her speed in meters per second, t seconds after the start of the race. For part A, we have to write down Carol's speed 3 seconds after the start of the race. So, if I draw a line up from 3 and then read across, we get 6.6. So we have 6.6 meters per second. For part B, we have to write down Carol's greatest speed. Well, the greatest speed is over here, and it's at 9.8. Next, there were 2 times when Carol's speed was 9 meters per second. We have to write down these 2 times. Well, if I draw a horizontal line across from 9, what we need to do is read the corresponding times. So, here we get 5.1, and we would also get 8.9. Question number 11. The first 3 terms of a number pattern are 1, 2, 4. Esther says that the first 5 terms of this number pattern are 1, 2, 4, 8 and 16. We have to write down the rule Hester could have used to get the 4th and 5th terms. Well, 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So we multiplied the previous term by 2 to get the next term, and then we have to write down the 6th term. So I've got this term 16, and then if I multiply that by 2, we get 32. So the next term is 32. Jack uses a different rule. He says the first 6 terms of the number pattern are 1, 2, 4, 7, 11, 16. What we have to do is write down the 7th and 8th term. Well, here we are adding 1, then we add 2, then we add 3, then we add 4, then we add 5, then we add 6 to get 22, and then we would add 7 to get 29. So our next terms, we've got 22, 29. Question number 12. Martin has 8 pints of soup in a pan. He also has 24 soup bowls. He puts 0.3 pints of soup into each bowl. How much soup has he got left over? So he puts 0.3 pints into each soup bowl, and there's 24 of them. So the amount he would use will equal 0.3 multiplied by 24, which is equal to 7.2. So we've got 7.2 pints. And therefore, if I do 8 subtract 7.2, we would get 0.8. So the amount of pints he's got left over is 0.8. Question number 13. Abby invests £500 for 4 years in a bank. The account pays simple interest at a rate of 2.3% per year. We have to work out the total amount of interest Abby has got at the end of 4 years. So what we need to do first of all is work out the interest for 1 year. So that's equal to 2.3% of 500 which is £11.50. Now we've got interest for 4 years, so we would have 4 times by 11.50, which is £46. Question number 14. The graph shows the cost of using a mobile phone for 1 month for different numbers of minutes of calls made. So we've got the number of minutes and cost. The cost includes a fixed rental charge of £20 as shown here. And then a charge for each minute of calls made. We have to work out the charge for each minute of calls made. Well, what we need to do is find out the gradient of this line. So what we need is a change in x, and we also need a change in y. Now here we are going from 20 to 35, so here we've got a change of 15, and here we are going from 0 to 500, so we would have 500. So what we can find out is how much it would cost per minute. So the cost per minute is equal to 15 divided by 500. So if I work this out, we get 0.03. So we get 0.03 pounds per minute for each minute. So that is 3 pence. Question 15. Here's a list of ingredients for making chocolate mousse for 2 people. We require 40 grams sugar, 110 grams dark chocolate, 2 eggs and a quarter teaspoon of lemon juice. Ellie has 250 grams of sugar and 550 grams of dark chocolate. She assumes that she has plenty of lemon juice and plenty of eggs. What is the greatest number of people Ellie can make chocolate mousse for? You must justify your answer. Well, if we think about the amount we've got for sugar, well, I know that 40 grams is for 2 people, and therefore dividing by 2, 20 gram for 1 person. So what I can do now is find out how many we can make with the amount of sugar we've got. Well, we've got 250 grams available, and if I divide this by 20, that tells me I get 12.5. So the greatest number of chocolate mousses I can make is for 13 people with the amount of sugar I have. Now let's apply the same argument with chocolate. With chocolate, we've got 110 grams for 2 people, and therefore for 1 person we require 55 grams. And therefore, to find out how much we can make, we would have to do 550, that's the amount of chocolate we've got available, divided by 55, which is 10. So with the amount of chocolate we have, we can make enough mousse for 10 people. So I'm limited by the amount of chocolate I've got, and therefore the maximum I can make is enough for I can make enough for 10 people. Now Ellie only has 6 eggs. What effect would this have on the greatest number of people Ellie can make chocolate mousse for? Well, we know for this ingredient we require 2 eggs for 2 people. So we've got 2 eggs for 2 people, and therefore if we've got 6 eggs, that means we can make enough for 6 people. And the way I worked that out was by multiplying by 6. And therefore, what can we say? Well, we can only make enough mousses for 6 people. Question number 16. A sprinter runs a distance of 200 meters in 25 seconds. We have to work out the average speed of the sprinter. Well, the speed that's equal to the distance, 200 meters, divided by the time, 25 seconds. And if we work this out, we end up with 8 meters per second. So we have 8 meters per second. Question number 17. For part A, we have to simplify 7x plus 2y minus 3x plus 4y. Well, here we have to collect like terms. In terms of the x's, we have 7x minus 3x, which is equal to 4x. And then we've got 2y plus 4y, which is 6y. So we have 4x plus 6y. For part B, we have to factorize 10x minus 15. Well, what's the highest common factor of 10 and 15? That will be 5. And then inside the bracket, 5 times by 2x will give the 10x, 5 times by minus 3 will give the minus 15. For part C, we have to solve 5p equals 3p plus 8. Well, if we begin by subtracting 3p from both sides, we will end up with 2p equals 8. And if I divide both sides of this by 2, then 8 divided by 2 is 4, which means p is equal to 4. Question number 18. There are 64 cards in a pack. The card is either red or black. The ratio of the number of red cards to the number of black cards is 1 to 1. 8 red cards are removed from the pack. We have to find the ratio of the number of red cards now in the pack to the number of black cards now in the pack. Give your answer in its simplest form. Well, if we draw a bar model, we've got the ratio of red to black being 1 to 1. And what we have altogether is 64 cards in total. So each card is worth 32. So we've got 32 red, 32 black. So therefore, if I do 32 take away 8, that means now there's 24 red in the pack now. So therefore, for the ratio of red to black, we've got 24 to 32, and if I divide through by 8, we will end up with 3 to 4. Question number 19. Here are a 4-sided spinner and a 5-sided spinner. The spinners are fair. Jeff is going to spin each spinner once. Each spinner will land on a number. Jeff will get a score by adding these two numbers together. For part A, we have to complete the possible space diagram for each possible score. So, adding the 1 and the 1, we get 2. 1 plus 2 is 3. 1 plus 3 is 4. 1 plus 4 is 5. 1 plus 5 is 6. 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. 2 plus 4 is 6. 2 plus 5 is 7. 3 plus 1 is 4. 3 plus 2 is 5. 3 plus 3 is 6. 3 plus 4 is 7. 3 plus 5 is 8. 4 plus 1 is 5. 4 plus 2 is 6. 4 plus 3 is 7. 4 plus 4 is 8. 4 plus 5 is 9. Here is the completed sample space. And then Jeff spins each spinner once. For part B, we have to find the probability that Jeff gets a score of 3. Well, how many 3s do we have? Well, what we have is 2 of them out of, well, how many outcomes do I have? I've got 5 by 4, so I've got 20 outcomes. So the probability is 2 over 20, which would simplify to a 10th. So I've got 1/10. And then for a score of 5 or more, well, a score of 5 or more, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 out of 20. Question number 20. Water flows through a pipe at a rate of 20 gallons per minute. 1 gallon is equal to 4.55 litres. We have to change 20 gallons per minute to litres per second. Give your answer correct to 3 significant figures. Well, we want gallons per minute to gallons per second. So, first of all, what we know so far is 1 gallon is equal to 4.55 litres. So let us convert 20 gallons. If we were to convert 20 gallons then what we have to do is multiply this 4.55 by 20 to get 91. So we would have 91 litres, which is equal to 20 gallons. So what we need to do is convert 20 gallons per minute to litres per second. So 20 gallons is the same as 91 litres. So here we've got 91 litres per minute. So at this point, what we would have to do is divide by 60 to convert it into litres per second. So what we have here then is 91. Then if I divide this by 60, I can convert it into litres per second. And if I work this out, 91 divided by 60 is 1.52. So we have 1.52 litres per second. Question number 21. We have to find the highest common factor of 32, 48 and 72. Well, let's create factor trees for each of these numbers. For 32, 2 times by 16 is 32, 16 is the same as 2 times by 8, and 8 is the same as 2 times by 4, and 4 is the same as 2 times by 2. So 32 is the same as 2 times 2 times 2 times 2 times 2. Similarly for 48, we would have 2 times by 24. 24 we can split up as 2 times by 12. 12 we can split up as 2 times by 6, and 6 we can split up as 2 times by 3. And the 72, we've got 2 times by 36. 36 is 2 times by 18. 18 is 2 times by 9. 9 is the same as 3 times by 3. So therefore, for the highest common factor, well, we've got 2, which goes everywhere. We've got this 2, which is common. And then we've got another 2, which is common. So the highest common factor is equal to 8. Question number 22, we've got shapes A and B, and we have to describe the single transformation that maps shape A onto shape B. Well, if I pick any point, for example this point, and the corresponding point is this point here, well, what you can see from A to B, I go 1, 2, 3, 4 to the left, and then I go 1, 2, 3 down. And so what we have then is a translation, and the vector is equal to 4 minus 3. Question number 23. The time series graph shows information about the percentages of people in a village that use the village shop for the years between 1980 and 2010. That's what we see here. And for part A, we have to describe the trend in the percentage of the people in the village who use the shop for this period. Well, we see that the percentage of people using the shop overall decreases. And then we have to use the graph to predict the percentage of the people in the village likely to use the shop in the year 2020. Well, what we have to do to begin with is draw a line of best fit. So if I draw a line of best fit, we would have something roughly looking like this. And then for 2020, well, we draw a line up from 2020 and then draw a line across, what we see is we've got 16. Now we have to think about whether our prediction is reliable. Well, what we can see is we've got our data set here and 20 is outside of this data set. And therefore, our comment is unreliable. Question number 24, for part A we have to expand and simplify 3 times by y minus 2 plus 5 times by 2y plus 1. Well, 3 times by y is 3y, 3 times by minus 2 is minus 6, 5 times by 2y is 10y, 5 times by 1 is 5. Collecting like terms, well, for the y's we've got 3y plus 10y, so that's 13y, minus 6 plus 5 is minus 1. So I've got 13y minus 1. For part B we have to simplify 5u squared w to the 4 times 7 uw cubed. Well, when we have the same base number, we add the powers. Now, first of all, 5 times by 7 is 35. Then we've got u. Then I've got u to the power of 2 times by u to the power of 1. So I add the powers in this case. And then I've got w to the 4 times w cubed. So I've got w to the 4 plus 3. So I've got 35 u cubed w to the 7. So I've got 35 u cubed w to the 7. Question 25. The diagram shows a regular octagon and a regular hexagon. We have to find the angle x, showing all our working. Well, first of all, let's find out the interior angle of the octagon and then of the hexagon. And then we can use the fact that the angles around a point sum to 360. So if I think about the octagon, then if I find the exterior angle, well, I would have to do 360 divided by 8, which is equal to 45. So if I show what that means, well, what it means is, if I extend one of the lines like so, this angle here then is 45 degrees. And now we have to find the interior angle. So the interior angle is given by 180 minus the exterior. 180 minus 45 is 135. So I've got 135 for this angle here. So let's add this on here. I've got 135. Now, let's do the same thing for the hexagon. For the hexagon, I can find the exterior angle by doing 360 divided by the number of sides, 6. The exterior angle is 60. So what that means is, if I extend one of these lines, like this one here, this angle will equal 60 degrees. And so we can find out what this angle here is by doing 180 minus that 60. So I've got the interior angle equaling 180 minus 60, which is 120. So this angle is 120. So in essence, this angle here is also 120. Now, what we know, angles around a point sum to 360, so I've got 135 added to the 120 added to the angle x. This is all equal to 360. So we've got x plus 255 equals 360, meaning x is 105. Question 26. Here's a Venn diagram. We have to write the numbers that are in the set A or B. Well, I've got 15, the 12, the 8, the 10, the 16 and the 14. So we need to write down those numbers as we see here. Now the set in A and B, well, I've got the 12 and the 18. Then one of the numbers is chosen at random. We have to write down the probability that the number is in the set A complement, so that means not in A. Now here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers in total. And of those 10, how many are not in A? Well, I've got 1, 2, 3, 4, 5, 6, 7 of them. So I've got 7/10. Question number 27. On a farm, the number of cows and the number of sheep are in the ratio 65. The number of sheep and the number of pigs are in the ratio 2:1. The total number of cows, sheep and pigs on the farm is 189. How many sheep are there on the farm? Well, what I need to find to begin with is the ratio cows to sheep to pigs. Now I've got the ratio of cows to sheep being 6:5, and I know that the ratio of sheep to pigs is 2:1. Now what I want is the sheep to be the same. Well, I can have 10 over here because 5 and 2 are both factors of 10. What do I multiply 5 by to get 10? Well, I multiply that by 2, so 6 times by 2 is 12. What do I multiply 2 by to get 10? Well, that's 5, so 1 times by 5 is 5, so I've got 12 to 10 to 5. So here is a bar model representing this information. I've got 12 to 10 to 5, and I know that there's 199 animals in total. So this total is 189. So you can see we've got 27 parts. So if I do 189 divided by 27, I get 7. So each part is worth 7. So each part is going to be worth 7. So for the total number of sheep, I've got 7 times by 10, which is 70. So for sheep, we have 10 times by 7, which is 70. So there are 70 sheep. Question number 28. The arc ABC is a quarter of a circle with centre O and radius 4.8 centimeters. AC is a chord of the circle. You have to work out the area of the shaded segment. Give your answer correct to 3 significant figures. Well, if I find the area of OAC, I've got the area of a triangle. So that's equal to 4.8 times 4.8 all divided by 2. So that's equal to 11.52. centimeters squared. We can now find the area of this quarter circle. The area of the quarter circle, I've got pi times by 4.8 divided by 4, and then this is squared. So if I work this out, I've got pi times 4.8 squared, dividing that by 4, I get 18.0, etc. centimeters squared. So the shaded area, well, I've got this 18.0, etc. Then I subtract the 11.52. So if I work this out, I get 6.58 centimeters squared, and this is given to 3 significant figures. So I've got 6.58. Question 29. ABC is an isosceles triangle with BA equaling BC and D lies on AC, and ABD is an isosceles triangle with AB equaling AD. The angle ABD is 72 degrees. We have to show that the triangle BCD is isosceles. So, what we know is if BA, which is the same as AB, equals BC and AD, that means AB equals BC, which equals AD. So what this actually means is this is equal to this, which is equal to this. So we know that this is 72 degrees, and if we know that we've got an isosceles triangle, that means that this angle here is also 72 degrees. So let's write that down. The base angles in an isosceles are equal. So what can we now do? Well, what I can do is find out what this angle here is, the angle BDC. BDC is equal to 180, subtract the 72, which is equal to 108 degrees. So this is 108 degrees because angles on a straight line sum to 180. Now we can also find out what this angle here is, recognizing that we have an isosceles triangle and angles in the triangle are 180. So the angle BAD is equal to 180 subtract 2 times by 72, which is 36 degrees. So this angle here is 36 degrees, and the reason for that is because angles in a triangle sum to 180. Now let's just adapt this. Let's change the colour there. Now we can instantly spot then that this angle here will also equal 36 degrees, so the angle BCA is equal to the angle BAD, which is also 36 degrees, and the reason for that is because base angles in an isosceles are equal, as we see here. So I've got an angle here, an angle here. So what I can do now is find out what this angle here is worth. Well, that angle DBC is equal to 180, subtract this 108, subtract the 36. So this angle is also 36 degrees. And that's because angles in a triangle sum to 180. So what can we say then? Well, as the angle DBC equals the angle BCA, which is equal to 36, we've got the base angles which are equal, which means the triangle BCD is isosceles.